Greetings from our group members. First of all, I would like to thank Dr. Abdullah Sharif for giving us the opportunity to present and share our presentation in front of our classmates. Our group members are myself, Muhammad Atif, Mr. Hani, Mr. Orabi, and Mr. Mustafa. We chose the topic of object detection using artificial intelligence. Computer vision has become advantageous and quite interesting, and many things like prediction and estimation, self-driving cars which are autopilots, robots like Sophia that uses visual data processing and facial recognition, medical abnormality detection that includes brain tumor detection, cancer detection, and various disease detection. Vehicle detection and surveillance, like traffic violations, are some of the motivational aspects due to which we were inclined towards choosing this particular topic. Now, we have organized our presentation structure into 5 main sections. That is general theme of all papers, brief for each research paper, comment analysis, interesting lessons learned, appendix. Appendix includes, that is the last section, and that includes references, glossary that states the acronyms and their abbreviations, followed by the research paper quality, and then before concluding, we will display the analysis metrics that we developed in order to perform the integrated analysis and make the connection among all the research papers. Moving to the next slide. So we'll start with the first section, which is the general theme of all the research papers. What is the topic about, paper overview, common research goals. So now, what is the topic about? The main topic is evolving around the object detection in images and videos. Some example of object detection are detecting tumors and cancer cells, in agriculture detecting different types of diseases in fruits and plants, whether the plant is able to produce well or not. And one of the prime global issue at the moment is, during this pandemic, mandatory mask detection, whether if someone is entering a facility or whether it's a university campus or an hospital, they should be wearing masks. Regarding video detection, let's say an example of video moving cars for traffic violations in sports, for example, football games, detecting the offsides of the player, which angle the balls are being passed to the another player. In the game of baseball, what is the hit prediction for a player? Even such researches can be used for training the players for improving their skill of the game. Object detection with combination with the classification algorithms are being evaluated by different various evaluation metrics, such as, for examples are accuracy, precision, speed, and some other evaluation metrics. These are used for performance analysis. Artificial intelligence is immensely benefiting the object detection in healthcare. For an example is detecting brain tumor, diseases, transportation, that is the autopiloting thing. In the retail, there is an example of it is unattended staff shops. Unattended, there is a unattended bank as well. Also for detecting, let's say, new species out of the trained model which were trained on dogs, cats, and different kinds of animals and other species. So a new species can be detected as well. So moving on to the next slide, I will now ask Mr. Hani to continue from here. Thank you.
Assalamu alaikum. My name is Hani Abdelhadi. First of all, I need to say thank you for Mr. Muhammad Atif for handing over, and thank you for Dr. Abdullah Sharif for giving us this opportunity. I'll talk about all the paper overview. First of all, I need to show how we gathering the research papers. There is some restriction for gathering the research papers. First of all, regarding the timing, we put in our consideration to bring a recent paper. It is more than 2016. As you see here, there is around 7 papers in 2019, and the rest already distributed between 2016 till 2020. And also we put in our mind to bring a very high quality paper, and it is already published in high journals. So there is a 7 paper from IEEE, and IEEE there is another 3 papers, and the rest from also a high journal and conferences. During the research, there is some keywords we put it in our consideration to search in a certain word, such as classification, object detection, artificial intelligence, and also to cover different fields like the medical fields, the robotic fields, the education fields, and also with the general fields. Now we will go to the second slide. In these slides, we will talk about the common research goals. We have analyzed the papers and we found the common elements in terms of comparing and evaluation different artificial intelligence algorithms. Most of the paper have proposed a new technique that were built by combining or adding a new steps in the existing artificial intelligence models. In our finding, there is a 13 papers were related to analyze the performance of object detection in static images, and 6 papers related to video detection, while there is another 8 papers also focused on the boundary issues for the objects. In object detection, the boundary and edges of an object need to be probably detected for better result. So we are concentrating in these researches into these 2 issues. Now we will go to the next slide. We still in the common research goals. We have shown the most common research technique in the graph, which shows experimental analysis, the training dataset, and evaluation is the most common technique. Furthermore, most of the paper follow approach. This approach is to propose a model or a technique, training the model with some public dataset or some specific datasets, perform an experimental analysis, and evaluate the model by using the metrics like the accuracy and the precision. The most common artificial intelligence algorithm used in 72% of our research paper is CNN, and its various type of CNN, such as regional CNN, fast regional CNN, and faster regional CNN. Most of the paper also used a public dataset like visual object classes like ImageNet, Pascal, common object in context. Furthermore, commonly used evaluation metrics were the accuracy, the precision, and the F1 score. Now we will continue with the common research in the next slide. Through our research paper, we found the CNN algorithm is the most algorithm has been used for image detection and video detection. Now I'll give a small brief about the CNN algorithm. When you have an image and there is an object inside the image, you need to classify which object you need to detect. So by using the CNN algorithm, it is very difficult to calculate. They came with another algorithm called regional CNN, which take the image itself and divide it to regions by maximum 2000 region to train the system for this region. After that, the CNN is extract the feature from these regions. Then they use the SVM as a classifier feature to classify the object. After again, then they make a boundary called a boundary box for each picture or each object. But still, it is very difficult to calculate and takes time for calculation. So the researcher came with another algorithm called fast regional CNN. In the fast regional CNN, they used a feature map. The feature map use instead of every time while the training, you provide the system with the 2000 region. In the feature map, you enter it only one time and it keeps the image inside the training set. But it still takes time for calculation. So the researcher came with a new model called faster regional CNN, and this one they use additional layer called ROI pooling. It used as a pool. This one every time the data came to this in this layer, and keeps for the calculation for the next time. Now the faster RCNN is a fast algorithm for detect the images and the videos. Now we will go to the next slide. In this slide also we'll talk about the evaluation, how the researcher evaluate the models. They use different type of evaluation. They use accuracy, precision, recall, and F-score. We will not go for details for these calculations, but we will give a small brief that if we have a confusion matrix, this confusion matrix, always we have the actual data set and we have the predicted data set, and we have different value. We have the, even it is true positive, false positive, false negative, and true negative. From this confusion matrix, we will start to calculate the accuracy, and we'll start to calculate the precision, the recall, and F-score, which most of the papers which we found it, they use this calculation to calculate the evaluation or to evaluate the result. Now I'll give the floor to Mr. Arabi to start with his section. Thank you.
Thank you, Mr. Hani, for handing over, and thank you, Dr. Abdullah, for giving us this opportunity. So starting from section 2, we try to provide more details for each paper in regards to the problem, objectives, approach, key points, main results, and the findings. So what we did is we tried to group all the research papers into two different categories. The first category, which focused more in the object detection and classification, and the second category, which talks mainly only about the object detection. So myself and Mr. Hani, we will talk about the first group. So with that, I'll move on to the first paper, which is the analysis of convolutional neural networks for image classification. The aim of this paper is to analyze the capabilities of CNN to categorize the sense in videos on the basis of identified objects. So that research was based on experimental analysis, and it used three public datasets. The first one is the ImageNet, second is the CIFAR 100, and the last is the CIFAR 110. So all of these datasets were being used for the training and the testing datasets. The approach of this research paper was to analyze three popular networks, and these are the ones which is the AlexNet, GooglyNet, and the last one is the ResNet 50. And all of them talks about, when it comes to the evaluation matrix, talks about the accuracy, and the result of that were GooglyNet, ResNet 50, they recognize the object with better accuracy comparing to AlexNet. The second one, I'll move this, is the smart unstuffed retail shop based on artificial intelligence and the IoT. Mainly the objective of this paper talks about the customer identification and the commodity recognition in the implementation of unstuffed retail shop. So with that, the research follows the approach of proposing a method based on, as you can see, mask, RCNN, and the Internet of Things. It's a combination. And the data set used for training the model include 11,000 images and 10 different type of stock keeping units, which is the SKU. The research used the experimental analysis to compare between the training and the testing data sets. The evaluation of this matrix, to be honest, it is similar to the first one, which talks about the accuracy as a main, and talks about the precision, missing rate, recognition rate, error rate, speed of the algorithm, and the processing time. As you can see here, the result of that revealed were 97.7% counting accuracy and the 98.7% recognition accuracy. So moving on to the next slide. So these two research papers are also sharing the same object detection and classification. However, like we noticed that both of these papers are, we group it here in the same slide because they are talking only specifically about the healthcare field. So the paper with the name, first one, is the convolutional neural network for automated fracture detection and localization on wrist radiographs. The object is to analyze the performance of an object detection, which is the CNN. So the object here is the fracture detection, and the second one is the localization on wrist radiographs. So the approach of the first paper here is to implement the ResNet faster RCNN architecture through an experimental analysis which evaluate the algorithm in terms of performance. And in order to do that, they use 7,356 radiographic images and 524 wrist radiographic as a data set. As you see, there is 7 evaluation metrics used as well. AUC, which is the area under the receiver operating characteristic curve, sensitivity, and the specificity, which is the main finding beside the localization of the radius and the fracture. So with that, the results of this paper reveal that the faster RCNN, it is able to localize, as you can see, 91.2% of all radius and localize 96.3% of ulnar fractures, which is quite high. Image sensitivity was 95.7, specificity 82.5, and the AUC values was 0.918. The last, the second one here is the artificial intelligence to diagnose the meniscus tears on MRI. The aim of this paper here is to build and evaluate the high performance algorithm to detect characteristics, to detect and characterize the presence of meniscus tear on MRI image of the knee. So with that, the approach of the paper is to propose an algorithm using the fast and the faster region CNN, and it is divided, as you can see, into 3 subtasks: the horns position detection, tear detection, and tear orientation. The algorithm here is based on, was trained on 1,123 MRI images and the knee of the knee, and the 700 images of external validation. So with that, the research performed an experimental analysis and using the evaluation metric, which is the AUC, and the results of that paper for the EOC itself, it shows as stated here is 0.92 AUC as a presence, 0.94 as a position, and 0.83 as orientation. And with that, I'll hand over to Mr. Hani to proceed, and thank you.
Thank you, Mr. Arabi, for handing over again. In the paper titled Object Detection and Recognition of Intelligent Service Robot Based on Deep Learning, the main objective of the paper is to train the robot to understand the surrounding and make intelligent decisions accordingly. The approach of the paper is to propose an object detection and recognition algorithm based on deep learning, followed by the training of the public image dataset. Further, experimental analysis was performed between algorithms that are DPM, RCNN, fast RCNN, faster RCNN, and yellow, and the proposed model by the researchers. The evaluation metric used were accuracy and speed with 3 different platforms. The main result and finding for the paper showed that good accuracy for image-based objective detection and recognition, different result for the video-based object detection and recognition. But in the second paper, which titled Traffic Signal Violation Detection Using Artificial Intelligence and Deep Learning, the primary aim was to the detection of the traffic violation in video. The approach was similar to the previous paper to propose a model, but in this particular paper, it is implementation and evaluation instead of experimental analysis only. The research implemented yellow version 3 algorithm for object detection. The model was trained on a public dataset of common object in context, and the evaluation matrix of the accuracy was used. The implemented system shows the accuracy of 97% for vehicle count detection and 89% to detect the vehicle speed. Now we'll go to the next slide with another two papers. In these slides, we have another two papers which followed the similar approach of proposing methods, training with dataset, perform experimental analysis by comparing the different techniques and based their result on the evaluation matrix. The top paper contributes towards the robotic advancement. The main aim of this research paper was to identify objects and predict the relevant action tasks that they could perform. For example, the knife predicted action could be even to cut or to spread. The research proposed a method based on CNN algorithm for object detection and action classification. And for the evaluation, the final score linear combination was performed. In this paper, the dataset used for training the method was not a public, and the evaluation matrix used for precision is the precision, recall, and F1 score. Now, the result of this paper suggested the proposed model has effective feature extraction method, and the Deciment algorithm performed better than the BRE algorithm. For the second research paper, the aim was to diagnose the disease in a grape veins. The proposed method was trained on a public dataset called Plant Village dataset, and then was compared with other 6 CNN algorithms, which is AlexNet, GooglyNet, Inspection version 3, ResNet 50, ResNet 101, and SqueezeNet. As shown in the slide, the evaluation metric also includes the most commonly used accuracy and F1 score as well. The result shows that method was from the methods around 34% better predictive value for the site and around 23 better than predicted value from the baseline system without deep learning. Further, the ResNet 101 and 150 were the best performer. However, the researchers didn't recommend to use the ResNet 101 due to the it takes time for calculation. Now we will move to the last paper to explain the paper number 5. Now we reach to the slide number 3 for the papers. In this paper, the primary objective is video prediction for real-world interactive agents. The approach is also similar to the last two research papers. This paper also proposed a model for video prediction. The model was trained on a public dataset of called Human 3.6M and a dataset of robotic interactions, followed by comparison with 3 prediction modules of DNA, cDNA, and STP. The evaluation matrix used in this paper was unique among all over the papers. This evaluation matrix used peak signal to noise ratio, PSNR, and structural similarity index measure, SSIM. The result of this paper shows the model produced video sequence more than 10 times steps into the future. Now I'll hand over to Mr. Mustafa, who will start the research paper that addressing the common objective detection aim.
Thank you, Mr. Hani, for handing over, and I would like to thank Dr. Abdullah Sharif for providing us with this opportunity to present. The top paper titled A Real-Time Computer-Aided Object Detection of Nasopharyngeal Carcinoma Using the Genetic Algorithm and Artificial Neural Network Based on Haar Feature Fear is based on the problem of inability to imagine the border points of the tumor accurately in detail, and the inability to separate the normal tissues from the undesirable ones that need to be removed being a part of the tumor. The research paper proposed a new method based on the genetic algorithm for MPC feature selection and ANN for an automated NPC detection from endoscopic images. The proposed method was trained on a dataset having a total of 381 endoscopic images, out of which 159 were tumor cases and 222 were normal cases. The research performed experimental analysis, and based on the accuracy, sensitivity, and the specificity as evaluation metrics provided the results. Experiments shows that the ANN classifier lists high accuracy of 96.22% and sensitivity of 95.35% and the specificity of 94.55%. Now, for the second paper on the slide, the primary issue was the limitation for conventional anchor-based detection due to the heuristic guided feature selection and the overlap-based anchor sampling. The research paper also followed similar approach of proposing a method. The method was based on feature selective anchor-free FSAF module with the anchor-based object detector. The proposed method was trained on a public dataset common object in context, which is named COCO, and further experimental analysis was carried on the FSAF module in comparison with the anchor-based counterparts. The evaluation metric used were speed and accuracy, which revealed that the result was that the FSAF module with the anchor-based object detector in images is robust and efficient in detecting objects. Also, it is faster than the normal anchor-based detectors. Now, moving for the next slide, the research paper titled Few-Shot Object Detection via Feature Reweighting is addressing the problem of bounding box annotation and availability for rare categories. The research proposes a few-shot detection module that learns generalizable meta features and automatically reweights the features for novel class. This module was trained on 3 public dataset visual object classes, which is the VOC 2007 and 2012 version, and also the COCO. Further experimental analysis was performed on the binary deep CNNs and using the evaluation metric of average, precision, and recall. The finding of the research showed that the model can learn to detect novel objects significantly faster and more accurately. The bottom research paper of the title Application of Deep Learning in Object Detection had the aim of studying the importance of deep learning technology applications and the impact of dataset for deep learning. The research baselined the evaluation metric of mean average precision of using faster RCNN with public dataset of VOC 2000. Further, it used the faster RCNN on the new unseen dataset. The finding of the paper showed that deep learning is an effective tool to pass man-made feature relying on the drive of experience, and also to the learning relying on the drive of data. And now I'm handing over to Mr. Atif. Thank you.
Thank you, Mr. Mustafa, for handing over. So I'll start with the first paper on the top, which is talking about salient object detection. that has become widely used as a pre-processing step in computer vision tasks such as classification. But still, it is quite difficult due to the factors like cluttered background. Such salient object detection techniques, they produce saliency map under the guidance of color, contrast, and texture, which are very low level feature. And still, it is very difficult to capture the relation of the object in context of the surroundings. Although CNN is a very good algorithm and it gives high level features to capture the foreground area, but still there are some challenges with it as it downsamples the activities which affects the original image resolution. Also, it adds an overloaded layer to integrate multi-level features that creates clutter, and also it can cause some incorrect saliency detection results as well. So the researchers, they propose a multi-branch model called Deep Embedding Features, DEF, for the detection, which composed mainly of 4 components. The first one being initial saliency network, followed by feature embedding network, and it's followed by recursive feature integration network, and the last component is the guided filter refinement network that produces the predicted map. So the proposed method was trained on 5 public datasets as shown on the slide. Further experimental analysis was conducted in comparison of 14 other methods. The evaluation metrics used were precision recall curves, F measure, and mean absolute error. The experiments on the 5 benchmark dataset shows that the proposed method achieve a real-time speed of 38 frames per second. So the bottom research, let me quickly move this over here. Okay, so the bottom research paper titled Object Detection Videos by High Quality Object Linking. Aim was to improve object detection in videos. So the researchers, they propose a method for cuboid proposal network that is somehow similar to bounding box method. So after detecting the short tubelet, after that they detected the short tubelet, that is kind of short video segments, and further they linked those tubelets together. So the proposed method was trained on the public ImageNet VID dataset. The researcher conducted the experimental analysis that are comparing 9 object detection methods with 30 classes of videos, and the speed of the video as well was one of the variable, which was either normal, fast, or slow. The evaluation metric of mean average precision was used, and the results revealed that the method showed improved results by 8.8% for fast moving objects. Now moving on to the next slide. So now on this slide, the top research paper aims to improve the discriminating regions optimization for object detection. So first of all, let me explain to you the discriminating region. What do we mean by that? So if the object is a bird, so the bird can be having 3 regions: the head part, the body part, and the feet part. So this research, they proposed a model which is, they named it as FDL model, which is the filtration and distillation learning model, and they used 4 public data sets. The names are shown on the slide for training the model, and they performed experimental analysis on the 3 CNN backbones, and the names are also shown on the slide. So the evaluation metrics after performing the experimental analysis, so the evaluation metric of accuracy, it suggested that the FDL model performs significantly better in identifying the regions properly, and with good performance. So the bottom research paper aim is to validate the theoretical claim of binary deep CNN to be 62 times faster and 32 times memory saving than the fully precision CNN. So the researchers, they proposed an algorithm based on the binary deep CNNs, and by using the three public data sets of Pascal, VOC, and ROG, they performed experimental analysis. The results that were based on the evaluation metric of mean average precision, it showed that successfully they were able to validate the claim which they made. Now moving on to the next slide. Okay, this is the last paper of our assignment. So this paper, it deals with the object detection, salient object detection, the boundary issue, and the edges detection issue. The research paper, it followed a method that included the skip layer structure. So for example, if something is in this object, it breaks down into layers, and if a layer is not visible or is not identifiable properly, so this model proposes a skip layer and connects just like a short circuiting, it short connects the two layers and tries to detect the missing layer or the unidentified layer. So in this process it connects through the HED, which is also called the holistically nested edge detector. On the other, one more thing in this method they use is the feature maps. Those are used in each layer of the object detection. So in this research they used 5 public data sets for training the model, and they performed experimental analysis among 12 methods. So they use the evaluation matrix, which is shown on the screen as well, and what in the end the result showed is this algorithm was actually performing 0.08 second better than the existing algorithms. Now I'll be handing over to Mr. Mustafa again. Thank you.
Thank you, Mr. Atif. In this section, we are going to share our comment and analysis, starting with the methodology analysis, then the opportunities we could analyze, and then the potential weaknesses we can suggest. We have identified 7 papers where the independent variable are nominal and are either one or two methods, and the dependent variable can be multiple but continuous. For such papers, we recommended the statistical test as t-test with 2 groups. Like we can see in this slide, for example, in paper number 1, there are 2 methods as the independent variable, and 3 dependent variables that are precision, recall, and F1 score that are continuous in terms of value. Likewise in the other papers. Now moving to the next slide, continuing with similar recommendation for the research papers on this slide, we can see, for example, in paper number 16, there is only one method as the independent variable, so that test can be using the method and not using the method. Further, the dependent variables are accuracy, sensitivity, and specificity, which are again continuous in nature. Moving on to the next slide, now we have another set of 7 papers where independent variables are 2 or more and with more values of those variables. For such papers, we recommend linear regression as the statistical test. We can see, for example, in paper number 2, there are 3 variables of methods, classes, and mode of speed, and within these variables, the possible value are more than 2. Moving to the next slide, for the remaining 3 papers out of 7. Similarly, the reason as discussed in the previous slide, we can see that the independent variables are either 2 or more with multiple possible values for each variable. Moving to the last set of 4 papers in the next slide, in this grouping, the independent variables is having more than 2 methods and are nominal in nature. And also, the dependent variables are continuous, and for such type of scenarios, a ANOVA test is recommended. As we can see an example of it, in paper number 4, it shows that there are 12 different methods as independent variables and 3 continuous dependent variables. Likewise in the other 3 research papers. At the end of this section, in summary, we group the papers according to the 3 recommended statistical tests, providing the appropriate reason for these recommendations. Now, I will ask again Mr. Arabi to take over.
Okay, so this section talks about the opportunity. We figure out 2 important opportunities from the research papers. And the first one talks about the data sets, where we found out there is a lot of papers they're using an old version of public data sets. An example is the VOC 2007 and 2012. Basically, these models could be trained on the recent data sets. So just give a quick example is the cars back 15 years ago, their shapes were significantly changed. So that really could help in traffic-related researches. Second one is the future enhancement in research, where the multi-object issue and boundary issue can be improved with the combination of reinforcement technique. So in like an example is we're adding a new reinforcement layer where the observers, when it comes to a training set, it is tested on a live ecosystem, I would say, and the observers give their feedback randomly. Moving on to the next slide, talks about the potential weaknesses. We figure out 3 important weaknesses. The first one where we found 17 out of 18 research papers were collected do not conduct a statistical test. And as we know, the statistical test, it really provides the important aspects where we need to have the mechanism of making quantitative decision about processes. Few of the researches, the second point, few of the research papers used similar data sets for training the model. Having diverse and large data sets, as we know, it can dramatically improve the learning capability of the model. I know we have to consider the computer power and the resources of the computer system which we have, but in general, the more larger data set and the more larger training data set, it will be the better the outcome. So with that, the last one is a few researchers use the keyword, we noticed that of precision and the accuracy interchangeably, and in fact those are 2 different evaluation metrics. That's what we figure out, and when we learned from the paper how it is how it was described. So just a quick example, we figure out like if we want to determine the like there's a person who have a cancer or not, we use on that aspect the accuracy. But if we want to detect the email spam, in this example, we may use the precision, and we can measure based on it. With that, I'll move on to the next slide, which is the interesting lessons learned. The first, it's quite a lot. I'll try to move it here. So the first one is the approach to conduct informatic research. That is proposing a model, training with the data sets, performing experimental analysis, and through the evaluation metric, which will conclude the results. We found out also that we could gain more as a brief introduction about CNN and its variation, which is really interesting part. Awareness about the public dataset available for training the model, which we personally it was really interesting to me. Evaluation metrics analysis, which also considers like an accuracy, precision, mean, absolute error, etc. So with that, these are the lessons learned, which has provided us a direction and will definitely benefit us in our future research work. Moving on to the next slide, here is the appendix. So now the appendix, as you can see, it has these 4 sections: references, glossaries, research paper, quality, and metrics and analysis metrics. This is the references in general. So here is 6, here is still 12, still 18, and this is the glossary we got, trying to just make it very clear when it comes to all abbreviations, I would say. And the last but not least is the research paper when it comes to research paper quality, which I'm referring to Mr. Zahani's point as well. It shows each journal or conference, the year of publication, and H-index, SGR, and the citation. And I'll will ask Mr. Hani to conclude this presentation with the analysis matrix. Thank you.
Now we will talk about the last part in the presentation, which regarding the analysis matrix. In this part, we did analyzing for all the paper related to the topics, related to the overview, which field we will cover, and which the objective for each paper and the problem to cover. And this is the numbers which we got. And this is numbers has been already displayed at the beginning of the presentation by the graphs which we used in the beginning, and Mr. Muhammad Atif talked about it. Also related to the common research techniques, which techniques have been used in the paper, if it is experimental analysis or evaluation or bounding boxes, and we found most of the paper using the same, the training set, the experimental analysis. Also, this is regarding the algorithm which has been used. Most of the paper, we can see it is using the CNN algorithm. Finally, here for also regarding the data sets. Most of the paper using an public data set, and the most public data set has been used, as we can see here, the VOC, the ImageNet, the Pascal, and Coco. This is also related to the evaluation matrix, the evaluation itself. Most of the paper used the accuracy, precision, F1, and speed. This is the last of the presentation. Thank you for all of you, and we are ready for the questions.